Good morning. I'm still CK and I still work for Akamai. Let's see if it's still true after the presentation. Well, it gets webcasted, right? So you never know. I was told to stand here and not play Steve Jobs and walk up and down because it screws up the podcast or the webcast. So let's see if I can stick to that. Good. Over the years, various people in Akamai have given presentations about how we work and what we do. And usually we put quite some emphasis on that we do not have a backbone, that we do not have a network, right? All of the various clusters which we are building, the servers, they are not just purpose-built. So when you're at an internet exchange, we build them exactly for these members, guessing how much traffic we will have, see what we need on a redundancy model, and then build one or two with a specific size. When we have the clusters on-net, which is basically, some people call it off-net, which is the clusters embedded in an eyeball network, then we build that particular for that network. They're all tailored, and then you get exactly the amount of servers we need for your traffic. And all of them are connected to the internet, but they're not connected to each other. They were independent from each other and had nothing really to do with each other. So in funny cases, like at Telehouse North, you end up with like 10, 20 clusters. They're all next to each other in big rows, but they were built for, either the LINX or the LoNAP, or they were built for particular eyeballs. But they didn't have really any connection between them. Then a couple of things have happened. So over the time, these clusters started, for multiple reasons, to talk more to each other. So one part is they report back to the mothership in Boston, right, for billing and monitoring purposes. But we also had something which is called the midgress traffic. So the clusters which had a cache hierarchy or an entry point for video or a storage or an archiver, they had to talk with the others. So over the time, more and more of the clusters talked to each other. But then that was still over their transit link to the other cluster. Now, as you can imagine, if you are connected to the internet and this is what you use, then you get all the fancy parts and problems which happen on a daily basis. So you have tromboning, the filtering problem, you have de-peering between providers, and all of that affects how the clusters can connect and talk to each other. You also have all the limitations of the particular internet, the MTU, does the provider you're connected to has IPv6 or not, the latency, which is particularly funny if you have two clusters next to each other, but you use two different transit providers, which decided to not peer in the same city, probably not even the same country. So now even if the clusters are next to each other, the connectivity goes out to London, might go to Frankfurt, peering to the other provider, and then back, which also from a latency perspective, not just from a cost perspective, is of course quite suboptimal. We discussed, and that is not different than the other people who build a backbone to solve that. But then whenever we looked into it, we saw that our clusters, and on one side this is what we always claimed, right? We want to be as close as possible to the end user. So suddenly now you have thousands of clusters all around the world, and now connecting them to actually get the benefit is not particularly easy because you spread them in the first place so much and so thin that they did exactly what they were supposed to be, close to the end user and deliver high performance and a good latency, but now connecting them together is quite an effort. So it took us a while till we had enough traffic between them, but also a business case, or till we were also annoyed enough with the latency between them and the costs, that we decided to build an own network. So this is what I'm talking about today, mainly is we call it the ICN, the Internet City Networks. There's nothing about a three-letter acronym. And this is really kind of similar to the other big content networks who did that before, like a Facebook, Microsoft, or Google. This is transporting predominantly right now the traffic between the clusters to each other. The idea is that over the time, whenever we either have more services who would benefit from that, or expanding the reach to more cities, and I will show where we are right now, that we would actually expand it and or put more and more of our services on it, probably peering, origin fetches, and other stuff. One of the main reasons why we did it was to save money. As you can imagine, if you have two clusters and you send the traffic up, you pay on one side, and then it really comes down on the other side, probably in the same rec row, then you pay for it twice, which is really nice, instead of just having a connection between both of them. It also, when you have a backbone, now you can actually think differently, right? You can now make a decision where you actually place the cache hierarchy on entry point and how you want to have the traffic flow. Before, we didn't care too much about that, or we put it with a transit provider which had a good reach. Now you basically can define where you want to put it, because you feed your own stuff, and you can decide where you want to serve. What we are not doing with the own network is actually becoming an ISP. So the idea is not to sell layer 3 VPNs or compete with the people which are our partners, which have servers in their networks. We do not desperately try to become a tier 1, and we also will not sell voice minutes or fractional STM1s to you, neither frame relay or ATM. So sorry for that. We built the backbone in different phases. So what we have right now is phase 1, which we finished in August last year. So quite a while ago. And you see, technically speaking, there are actually like 3 backbones. There's a significant part in the US, which covers the 9 metro areas, the big 4 cities in Europe, the FLAP, as we call it, Frankfurt, London, Amsterdam, and Paris. And, well, if you want to call a 100 gig link a backbone in Asia, might be a little bit too much, but a connection between Tokyo and Osaka. So we basically went where we had the low-hanging fruit, the most traffic, and where it made the most sense. So currently we deliver 3.5 terabits between our sites. And again, this is just the cluster traffic where the clusters are chatty to each other. The ICN, the backbone itself, has 15 cities, and the IN, this is how we call the metro networks. We have 22, but some of them are not yet connected to the rest of the network. We currently work on phase 2. We are somewhere in the middle for that, where we add another 10 global cities. So now you see that Asia, and especially Europe, gets a much bigger reach. And we also start to connect them with submarine cables together. So now it actually is a backbone and not just 3 different islands. One of the ideas also with the backbone was to offer something which we call direct connect, to which I come in a second, and eventually also give us the opportunity to do peering, not just on a per cluster base, but on a per network base, and fetch the origin. Right now we fetch the origin, independently for every cluster, which comes then over the particular transit. For the clusters which we connect together, we then can fetch it one time, transport it ourselves. Instead of that, the ISP has to transport it to that particular cluster. This is how it currently looks like. There's no technical presentation without a couple of network diagrams. So one of the things which we looked into in the beginning was what kind of topology we want to have, how does that look like, which kind of router, and how fancy and complicated will it be. We have then settled for actually a relatively conservative model. So what you see on top is what we call the ICN. So these are the backbone routers which are connecting the various cities together. The lower part, the medium level, the IN, are our metro routers. So there are 2, or you will see later in an example 5 or 6 in London, and they are connecting then the eCores in the lower part together, which are basically all the various clusters we have. So all the clusters which are in the data center are now connected dual-homed to a metro aggregation layer, and that one then to the backbone part. All the big private peers, potentially all the big internet exchanges and stuff, will end up on the aggregation layer sooner or later. And in the middle, you see the ADC boxes, which is basically Akamai Direct Connect, the one I will come to in a second. One of the benefits when you start from scratch is you don't have much technical depth, pretty much none. So then the question is, what kind of boxes are you choosing? How does the topology look like? And one of the things we said from the beginning, we start with 100 gig boxes only. If it's not worth to build a 100 gig link and a 100 gig wave, then we're not even going there. So all of the links you basically see are n times 100 gig, depending on the need. Akamai Direct Connect. So this is an interesting point. For many, many years, people came and say, well, I want to connect to you, mainly customers, and hand over my, instead of via transit, my content to you and your storage and your entry point directly. You have so many clusters, I just buy a cross-connect in a data center, and then can I give it to you directly? And we always said no and had to turn the customer away, because end of the day, when you have a couple of thousand clusters and the customer is just connected to one, that doesn't help with the distribution for the rest, right? So we say, well, you can connect, but then you reach exactly the people which are connected to these clusters, probably just a subset of London, and the rest of the world has nothing of it because there's no connection between them. So now when you actually have a backbone, you can give customers an opportunity to connect to you directly. So whatever they have on their side, the origin server, the encoder, it's usually more a media product. Now they can connect to dedicated boxes. So we accept now cross-connects, local loops, and stuff. And then from there, they're connected to the backbone. We transport it now to the archive or to the storage home ourselves. This is an example for how the US looks like more or less right now. So right now we are upgrading to a second fiber provider. So you do the usual thing, not very different than what you guys did for all the years. You have two different fiber providers for redundancy. In that case, we decided to pretty much go for kind of a mesh. This was mainly coming from how the clusters talk to each other. So we basically analyzed where's the content, how do they talk, and then modeled the network after it. This is a little bit easier than when you go to a new POP, for example, as an ISP, because you always have a little bit the guessing. Will I have enough customers? How much traffic will they do? In our case, we basically build where there's instant demand. We already know which cluster talks to which cluster for which reason. And then when they reach a certain threshold, which is usually covering the costs for the router and the fiber, then we can roll it out and build it, and it makes sense from day one on. Same for Europe. The upper part is London. So this is now an example how it grows horizontally. The ICN, the metro boxes. In case of London, we already have 6 of them connected to the 2 backbone routers. So if we pop more data center, if we spread more in a particular city or the capacity, you need more of the boxes, then we just grow horizontally for both the metro but also the backbone router if needed. And then the APJ part. So having worked at 2 different, or multiple different ISPs, but 2 different global ISPs and carriers in the past, whenever you come to the point that you build a new backbone, you get very excited in the first part, right? So now I buy the biggest boxes, I make the biggest network, I put all the different features in it I just can't possibly imagine, and this becomes state of the art. And then after 60 seconds, you say, yeah, probably not. So one of the parts which we looked into with the experience the different people in the architecture department had was how do we actually are carefully from day one with the technical depth we are acquiring? How do we actually ensure that we don't overcomplicate it, make it too fancy, and then you get locked into a technology, you get locked into a vendor, you build something which is then hard to support. So we did actually the opposite approach. How can you actually make it as simple and stupid as possible? And we looked for building blocks, which we have to have. So, you need a layer 3 box, of course. You need an IGP. We have chosen the classical ISIS, nothing specific there, a BGP to connect them together, an MPLS, which I show in a second. But make it as simple as possible so that you can choose vendors. as you want that you potentially can have your own box as well, and you're not locked in by any definition. And then do all the magic and fancy stuff, whatever that might be, an SDN version, a segment routing on top of it. So we have seen it more like as a Tetris model, right, where you then take building blocks out without affecting the rest. For many, many years, well, from the beginning on, we had what we call the mapping software, and you might have heard about it. So this is the global distribution which is responsible for sending you to a specific cluster. This is not just helping the eyeballs to find the right cluster, it also makes a lot of internal traffic steering. So end of the day, this is pretty much our version of an SDN. So we decided whatever we want to have on particular fancy features, we wouldn't use them from a provider or from a protocol, but try to do them in our own software as we did before, and have the network then as easy as possible and hopefully not acquiring much technical debt. Two quick examples. As I said before, we have ISIS and BGP route reflectors, setups and stuff like that. It's not even worth a slide. For the MPLS part, is the gentleman from Juniper still in the room? He will be very disappointed about this simple setup. Sorry for that. We were looking what do we need from a traffic engineering perspective, and how little as possible can we activate of that. So we were settling for two parts: the classical fast reroute, where you then have path pre-signaled in case of an outage, and the auto bandwidth, which made it easy for the state of the network and for the size we have right now, right? It's still, in comparison to some of the networks you have, relatively limited. Then, you configure various LSPs, and if one gets full, one link, then, it forks off the LSP over another path. And both of that, like in the 3-4 terabit range we have right now, works all fine and is not much of a problem. So again, we try to have as little as possible of the fancy features. Oops. Now my fancy slide is missing. Well, one of the things which we looked into for the future, the missing slide, is where does that go from here? So on one side, you already have seen we have a phase 2, so the network will grow whenever we have enough demand in a particular city or metro, which justifies the cost for the fiber. We basically connect them back to the backbone, so we will get more and more cities and more traffic on it. This is relatively easy and straightforward. One of the parts is, the other part is the origin fetches I mentioned before. So right now the clusters just talk to each other. But when we have rolled out phase 2, what we want to do is we move the peerings to the ICN. So whenever we peer with one of you, then especially when it comes also to PNIs in multiple locations, then the origin fetches basically can hand it over cold potato instead of, like a hot potato where you transport it right now to a cluster which consumes it. You just hand it over to the next PNI and then retransport it. So pretty much like any other ISP. Another part we work on and look into is the question how much, and that has a similar dimension, I guess, than London 2, how much of the boxes are you doing yourself? So you might know or not, for many, many years we built our own servers and our own hardware for the clusters. But we also have, since quite a time, own switches with an own operating system, white-labeled. So now the question comes, as you defined by intention, easy building blocks, to which degree can you now build your own router and do these kind of things yourself in case you want that? Another point we looked into is if the network is easy and you put every feature into the mapping or the SDN component from Akamai, then at which point are you giving the SDN basically like a segment routing, a pass, making them a customer or the owner of the network that they can signal their own part through the network, and then everything is in the Akamai logic rather than on the network part, and the network is relatively dumb and straightforward. So these are the parts we look into for like the next phases and an evolution part. So more bandwidth, but that's kind of the boring part, but also more in-house switches, routers, and putting everything of the fancy features upwards to the higher layers. And that's pretty much that as an overview. Questions, comments? 3 hands.
Hi, Rob Golding. Just for clarification, when you say your backbone and your submarine cables, do you actually mean they're yours, or do you mean you're renting them off of a supplier?
I did not say my submarine cable. No, we are, here. No, these are all leased waves right now, certainly for the submarine cable as well. You know, for fiber, you do the usual part, right? You try to figure out when it actually makes sense, when you have enough capacity to do a spectrum or IRU or other stuff. But right now, with the amount of capacity we have, we basically live off wavelengths. So this is all rented, different providers, but all rented capacity.
Cool. And then the second part, just ballpark, because I realise obviously it might be sensitive. What does a submarine cable cost these days?
Well, it depends on where you go.
Well,
right?
where yours went around Asia. What sort of number range are you talking for a submarine cable?
This really depends, right? So I'm not even sure if I have a factor of difference in my head easily. But as you have seen, we have the Brazil part, right, which goes down, and we have something in Asia. So the Asian part in comparison to like a transatlantic, huge difference. You would be surprised, up to the factor of 5 till 10 or so. So they're not even close to each other. So where you have, I think it's a classical part, right, where you have less providers and less options to choose, and especially as they get longer in Asia Pacific, then the price just goes up. Neil, I'm glad you came today.
So am I.
What would have been my presentation without your question?
My question was how much of this is new versus old? Because I find it surprising that you would go with almost a 20-year-old kind of architecture on something that's brand new, and not use more modern features and capabilities that are out there. I get the need to try and keep it simple, but I think if I had the chance, if in my world, if we didn't have a network and I had the chance to build it, I wouldn't be building what we built 20 years ago.
So is that more a question about the design and the topology, or is it more about the features activated?
Probably. I mean, topology is topology. It's global. You've got to go to countries. There's not a huge amount you can do about that. But using something like so you mentioned segment routing, but you didn't talk about too much detail about it. Which and I don't claim to know a lot about your internal traffic, but I could see how that would be really helpful to to you guys, and how that might help you deal with some of the challenges and issues you might come across, and also it might save you a load of money on diverse paths that you might not need as much. It just kind of feels a bit strange not to take advantage of that when you've got a clean sheet where you can test and trial things with low risk.
I think there are two things which are different between us and like an ISP. So one part is actually the operational component, right? All of you who are on ISP have a NOC and people who are looking after your routers, your links and everything on a 24/7 base. We didn't have that before, right? Because we didn't have a network. So we were much more focused on the server. Sure, we had a NOC, actually like 3 of them, but they are server people. They look if the servers are up, if they have a certain capacity, but they are not people who troubleshoot links or have understanding of MPLS and whatever. So the amount of features we introduce into the organization has to fit to the skills and the training we can provide to the people. So that is a little bit a challenge to a certain degree. How fast can you actually adopt something? But whenever we needed a feature, and now I get probably quoted on segment routing, even if that isn't where I wanted to go. It was more an example of a technology. But when we look into a feature where different network elements can actually talk to each other and then provision a path through the network itself, right? A direct circuit or something like that. Then with a certain guarantee between two locations. Then the question is, do I now do that in a router, or which features I already have in the mapping system? Because the mapping system already knows who speaks to who, right? They already have an idea why that is the case, or if there would be a second cluster. So the SDN component, to a certain degree, can make the decision, do they have to talk, or what is going on? So instead of now implementing it into the network, the question is, what can I do faster? Do I do it in my own software, which I already have, right? I don't have to establish that. Can I add a feature, or can I roll it out in the router? And does that lock me in? Does it work with my platform? Not all the feature works with every platform, right? So now we have that balancing act in between. And I think for most parts, we try to do it in our own software. So the lack of fancy features, either we didn't come across them yet, or we actually put them into the own software.
So yeah, okay, which makes sense, because so in effect you just want good layer 2 or layer 3 connectivity between, and you'll manage everything else as kind of like an overlay.
Yeah. Or at least a lot of the
which I guess is kind of my question. A lot of that's already there. It's the transport part's the bit that wasn't there before.
Yeah.
Yeah. Okay. Cool. Thank you. Good presentation.
Thanks.
Thomas Mange, Networks. So if I get it correctly, in the past, to open a POP, you wanted some colocation space and some transit. Does it mean that now, if you want to go to NuaX, you can say, I would like some colocation space and some layer 2 to another POP, or you will not be able to do that?
That's a good point, and I actually should have elaborated on that more. I was probably too quick and jumped over that. The backbone parts which we built, they are actually just, so thanks for the question, just connecting together carrier-neutral data centers and clusters which were there. The clusters which are in your eyeball networks, it is not that tomorrow someone knocks at your door, comes with a fiber and say, now we got to connect it back to the backbone. They are independent from us, from the backbone. So we will still keep all the clusters in the eyeball networks, just the parts with the infrastructure is actually the part which we connected together. This said, there are actually in the future, somewhere in 2019, things which we look into where we want to make the life of the people who have an own cluster easier. One thing, for example, we look at a certain amount of feed into the cluster. All of it comes via the transit of the provider, fair point, but some comes via hosting from wherever our customer is, the origin server to the cluster, and then gets multiplied, right? And some comes from our own infrastructure. So in the future, for example, if you appear with us at LINX, we can feed the part from our cluster via the LINX peering into it, so your transit bill goes down, and it makes actually the life of the eyeball networks easier.
Thank you.
Thank you. Hello, this is Bao Yuan from JISC. We have quite a few 10 gig and capacity and private peering capacity with Akamai.
Okay.
And we notice the traffic, we still have a capacity on the private peering, but peering with Akamai coming from the LINX and from Global Transit. Mm-hmm. And I'd like to understand your routing policy, because mm-hmm. of course we prefer use private peering as much as possible. Mm-hmm. So what is your policy to send traffic over to us?
Mm-hmm. I will explain it quickly because it's a more specific case, and if it doesn't answer your question completely, we can also talk in the break. Okay. So in general, we try to honor as much as possible if we have a direct setup in your cluster, in your network, and use that first. The second priority would be PNIs, the third IX, and then the last one transit if you have no other way to reach you. This said, now it depends on a couple of other factors, which makes it actually a little bit complicated. So one part is, if the cluster in your network is not very big, then it will not hold all the content. So then we still have to serve content from other clusters into your network, and for that we then choose different paths. So that is one reason why, even if you have own clusters, there still might be something from peering or from transit. It depends on which content is where located and how much we can put into the cluster. That's one reason. The other part is a performance, right? We look very much into the performance aspects more than into AS hops or into the other parts. As we can with a mapping system direct where we serve from, we can not override, but we use BGP as a transport layer, right, and the routing part, but then we can make a decision with the DNS which cluster we actually serve and send end users to. And if one has a better connectivity or the content is in it and versus another one where the content is not in, then you basically get these effects that you get served from multiple places at once. That is the short answer. If you think that the ratio is really out, then we should have a conversation and have a look how your network specifically looks like. And then if we did something wrong, or the algorithm decided to do something fancy, that we can do, but that is roughly the underlying logic how we serve.
Okay, so we're offline. That's
Coffee break.
Thank you.
Anything else? Nope. Well, then thanks a lot and have a good tea break.
Thank you, Christian.